explore the science of pop culture as we see what's real or unreal. Houston, we have a problem. I forgot my spacesuit!
T-minus 10 and liftoff.
For decades, movies have explored humans in space. And unfortunately, many characters find themselves in space without a suit. From 2001, A Space Odyssey to Princess Leia in Star Wars, even Gamora in Guardians of the Galaxy. Often we have these characters in the one place where they need a spacesuit, and they don't have it. So without the Force, how long can a human body actually survive in space? Let's find out. Well, first off, I guess it's important to define how space is different than here. You've probably often heard space referred to as a vacuum, and that's just it. It is. There's nothing there. No matter, no gas, not even atoms. It's mostly empty. And now while space isn't entirely empty, it's pretty close to it. The average density of space is only 5.9 protons per cubic meter. We just happen to live in this incredibly dense region of space that we call home. They say that in space, no one can hear you scream, and they can't. Sound is just energy vibrating through the air. Without air to propagate it, you don't hear anything. And that's not it. Without an atmosphere, there's no atmospheric pressure. And without that pressure constantly on your body, that's when things really start to go strange. So on Earth, we're exposed to 1 atmosphere of pressure, or 101.3 kilopascals. A pascal is a unit of measurement of force per area. So you can think of this as the force of the atmosphere exerts down on the surface area of your body at all times. Now, when you're suddenly exposed to vacuum, the air in your lungs is actually still at that 1 atmosphere, 101.3 kilopascals of pressure. And if you don't get rid of that oxygen, your lungs are going to do that for you by violently decompressing. So what you need to do is immediately exhale all that oxygen. Now, once you've exhaled your oxygen, your actual threat is going to be lack of oxygen. So how do your lungs work? Well, your lungs have blood pumping through them that gets very close to that air. And the blood absorbs the oxygen and delivers it to other parts of the body. As soon as your lungs are at a vacuum, then all of a sudden they start to suck air out of your blood instead. This deoxygenated blood travels to your brain in about 15 seconds, renders you unconscious. And at about 90 to 120 seconds, it's fatal. This is the real danger of space travel. Check out Jim LeBlanc, a NASA astronaut who was exposed to vacuum for 25 seconds. Another major problem with exposure to low pressure is something called ebulism. Ebulism is the spontaneous transformation of water droplets into water vapor at body temperature at low pressure. So effectively what this means is that the water in your eyes, your saliva, even the water in your bloodstream starts to boil off and create water vapor. At the very least, what ends up happening is that your body starts to swell due to trapped water vapor under the skin. So this is the part that's really going to blow your mind. The temperature of deep space is about 2.7 Kelvin, or minus 270 degrees Celsius, the temperature of the cosmic microwave background. On Earth, temperatures even approaching that cold would freeze you like this apple. But here's the thing, heat transfers through 3 methods: conduction, convection, and radiation. You lose body temperature by touching a cold solid object. That's conduction. You can also come in contact with cold liquids or cold gases, and they can leach heat from your body. That's called convection. But in space, there's none of that. There's no solids, there's no liquids, there's no gases. So that just leaves you with radiation. And the truth of the matter is you really don't lose that much body heat through radiation. So we do the demo, container of liquid nitrogen. Liquid nitrogen sits at minus 196 degrees Celsius. When this apple comes in contact, it freezes almost instantaneously. But that's because of the close contact, conduction, convection. Notice I can pick up this container with my bare hands. So why isn't that container super cold? And that's because there's an air gap in those walls, a little tiny vacuum. And that means only radiative cooling can take place. And really, it doesn't cool it that much. That's how the insulation in your house works. So how long does it take to freeze in space from radiation? Well, on the short end, maybe a dozen hours, but if you absorb heat from the sun or other stars, you may never freeze in space. So you're trying to get from one airlock to another and you've lost your suit. Will you survive? Well, it seems like your best bet is to exhale and hope you make it there in 15 seconds. Never freeze in space. You might just have the horror of being alive.